Good day, everyone. My name is Ryan Orr, and I'm a Senior Cyber Analyst in the Department of Homeland Security's Cybersecurity and Infrastructure Security Agency. I'm a subject matter expert on fifth-generation mobile networks, and I support key analytical initiatives, including 5G, cyber supply chain risk management, and communications infrastructure analysis. I am honored to be here today, and I really appreciate the opportunity to brief you on 5G risks and some security concerns that we've identified with open radio access networks. At CISA, we are focused on securing and protecting against risks to critical infrastructure. Wireless networks like 5G can pose risks if not properly secured, and I hope this presentation illuminates some risks that we've identified in our coordination with partners from federal government and industry. And while I'm not there in person, I look forward to answering any questions that you may have about my presentation or the cybersecurity risks we all face on a daily basis. Please feel free to reach out to me or the team here at CISA with any questions. Thank you so much. Before I begin this presentation on 5G risks, I'd like to touch on CISA's role in 5G. In March of 2020, the National Security Council issued the National Strategy to Secure 5G. This national strategy outlines and expands upon how the U.S. government can secure 5G infrastructure, both domestically and abroad. CISA is supporting that through our own CISA 5G strategy. Our strategy aligns with the national strategy and advances the deployment of a secure and resilient 5G infrastructure. Our vision is to enable the deployment of 5G and all related technologies, ensuring that it enhances our national security. Our strategy is built upon CISA's three core competencies of risk management, stakeholder engagement, and technical assistance. The CISA 5G strategy outlines 5 strategic initiatives which address critical risks to developing a secure 5G network. Those initiatives include supporting 5G policy and standards development by emphasizing security and resilience, expanding situational awareness of 5G supply chain risks and promoting security measures, partnering with stakeholders to strengthen and secure existing infrastructure to support future 5G deployments, encouraging innovation in the 5G marketplace to foster trusted 5G vendors and software development, analyzing potential 5G use cases, and sharing that information on risk management strategies with our partners. In order to support these initiatives, the U.S. federal government coordinates with international and industry partners to analyze risk and develop products. One such product we developed was in coordination with the National Security Agency, the Office of the Director of National Intelligence, as well as industry partners through the Enduring Security Framework Working Panel. Our particular working panel was tasked with identifying threats to the development and deployment of 5G. In order to address such a broad request like 5G threat, we broke down our work into 3 phases. For the first phase, we took a holistic look at 5G threat overall and bucketed it into 3 primary areas. Those areas include policy and standards, supply chain, and 5G system architecture. In the second phase, we took each of those high-level buckets of threat and broke them down into more specific threat vectors. And lastly, for the third phase, we developed illustrative scenarios for each of the primary threat areas to provide context and make the threats more understandable and relatable. The first threat area is policy and standards, which really are the backbone of what 5G is. Whether they are identifying use cases for 5G, which clearly outline how 5G will be used, or technical specifications that secure data as it flows through 5G networks. Through global standard-setting bodies like the Third Generation Partnership Project or the International Telecommunications Union, standards development influences the design, security, and architecture of 5G and any emerging technologies that utilize it. That's why it is so critical that these standards bodies and policies continue to stay open, transparent, and consensus-driven. Which brings me to our first threat vector, which is open standards. The potential exists for standards to include untrusted technologies and equipment that are unique to a specific company or country. While most standards bodies are multi-stakeholder and merit-based, these standards may still be influenced, which can put the trusted IT and communications organizations that build and design 5G technologies at a significant disadvantage. Our second threat vector under policy and standards is optional controls. Standards bodies develop protocols for mobile telecommunications, some of which contain security controls that are either required or optional. Should network operators decide to not implement optional security controls because they may impact other systems in the network or lock down protocols in the network that it needs to function, it may make the network more vulnerable and at higher risk for cyber attacks. In this paper, we also developed scenarios, which are meant to provide the reader with an illustrative understanding of a topic that can sometimes be very complicated and technical. I won't have enough time today to go over the scenarios, but we will share a link at the end of the presentation where you can see the scenarios we developed for this product, and you can also reach out if you have any questions or concerns. The second area is supply chain. And as we've seen with the devastating SolarWinds software supply chain attacks, it's absolutely critical to identify threats to your infrastructure through the supply chain. Entities could be exposed to supply chain risks through the use of 5G components manufactured by untrusted companies. These risks may include the insertion of malicious software and hardware, counterfeit components, and component flaws caused by poor manufacturing process and maintenance procedures. We identified two primary threat vectors, the first of which is counterfeit components, which are more susceptible to cyber attack and are more likely to break because of their poor quality. This is of particular concern when it comes to 5G, since it will have such a larger infrastructure of components than previous wireless generations. Where 3G and 4G used macro towers to send out signal over a large area, 5G utilizes small cells, which will be pervasive and located everywhere, as well as use massive input and massive output devices and macro towers. So ensuring that the device you buy is from a trusted component manufacturer reseller is critical, and we would recommend to not buy devices from untrusted resellers. If you are buying devices and you find a site that you've never heard of, but they are offering the same device at half the cost, there's likely a problem as to why it's so much cheaper, and it could very well be a counterfeit device. The second threat vector is inherited components, and this is the one that keeps me up at night. Essentially, threats coming from an extended supply chain consisting of third-party suppliers, vendors, and service providers. This is the type of attack that we saw with SolarWinds, where a software or component could have malicious software or hardware inserted into it through the supplier or even a supplier of the supplier. Flaws or malware inserted early enough in the development of a product can make it much more difficult to detect and could lead to the developer marking the component as legitimate through digital signatures or other approvals. Our third threat area is 5G system architecture, and within it, we identified 7 primary threat vectors. For today's presentation, I will go over 2: the inheritance of legacy vulnerabilities and edge computing. Unlike previous generations of telecommunications, security for 5G was designed from the onset and developed to meet increasing data, capacity, and communications requirements. However, even with those new capabilities built into 5G, both legacy and new vulnerabilities may be exploited by malicious actors. These include the increased attack surface due to the larger size of 5G infrastructure over previous generations of wireless networks, legacy vulnerabilities in legacy networks, or even new vulnerabilities that may be identified as 5G continues to roll out. It's a common misconception that 4G will just be ripped out and 5G will be installed in its place. In fact, initially 5G components will be mostly radio access components, all of which will still be using the 4G backbone to transfer data. So, essentially for the first years of a 5G implementation, only the cell phones and the devices they connect to, like the radio access network, will be 5G enabled. The backbone or the core network will still be 4G. It may be upwards of 2 to 5 years until that 4G backbone is fully replaced with a 5G one, meaning that any vulnerability that currently exists in the 4G network may be inherited into 5G networks. As an example, a malicious actor may want to attack a 5G network. However, with the increased security capabilities, it may be difficult to find a vulnerability to exploit. The malicious actor could find a common vulnerability in the 4G network, something like SS7, and use it to attack 5G components. The second critical vector we identified is edge computing. The integration of untrusted 5G core functions into the radio access network and the transition away from traditional network boundaries increases risk to the telecommunication networks from equipment previously thought to be less critical. Components such as small cells and base stations that traditionally did not have logical access to core networking components are now just as risky to insert. In order to mitigate this risk, it is important to avoid the use of hardware or software from untrusted entities, because those components may impact the operations of both the core and edge portions of the network. Because of this new dynamic enabled by edge computing, the distinction between core and radio access networks is blurred, making the insertion of untrusted components into either network similar from a risk management perspective. To reduce security risks associated with the implementation of 5G technology, network operators should use only trusted providers and encourage the continued development of trusted 5G technologies, products, and services across the entire 5G ecosystem. Some potential consequences, should these vectors be exploited, include, but is not limited to, the reduction of competition in the 5G marketplace, compromised supply chains, improperly configured 5G systems, which may be easier to attack, and potentially more accessible core networking systems. If these risks are left unaddressed, any of these potential consequences could lead to the theft of sensitive data and the loss of service availability, the degradation of customer and stakeholder trust in the organization, and could also lead to the erosion of public confidence in the reliability of the networks in question. You may be asking yourself, so what's the bottom line? Sometimes it's difficult to hear something like, you are more likely to have sensitive data stolen when you use untrusted components than it is to actually quantify that into real impacts. One of the ways that we are trying to do that is through an economic lens, but that can be very difficult to express. For example, if a company using untrusted components is hit with a ransomware attack and is down for 5 days, you could look at that and think, we lost 5 days of revenue. However, there are many ways that consequences come out that are much harder to quantify. What is the cost of losing public confidence in your organization? What is the cost of losing sensitive information to a primary competitor? What are the long-term costs of having untrusted components that require higher security, maintenance, and labor costs to support? It is important to consider all of the potential consequences and their associated costs when determining how to design and implement a 5G network. Next, we have opportunities to mitigate 5G risk. Government and industry have the opportunity to work together to maximize the benefits of the next generation of communication networks and to promote security and resilience associated with emerging 5G technologies. Given the expected rollout schedule, we have a short window of time in which the United States and allied countries can advance risk mitigation efforts that may be more difficult to address as the deployment of 5G networks advances. Some of these opportunities include encouraging continued trusted development of 5G technologies, services, and products. For some companies, reliance on untrusted 5G technologies is likely in part because of relatively low costs. National investment in research and development, economic incentives for manufacturing and buying trusted components, or economic deterrence for purchasing and installing untrusted components could increase trusted production and lower risks. We can also promote international standards and processes that are open, transparent, and consensus-driven, and that do not place trusted companies at a disadvantage. The U.S., industry partners, and allied countries could support this initiative by achieving greater representation in the ITU, 3GPP, and other standard organizations. Another potential opportunity is the continued engagement with the private sector on risk identification and mitigation efforts. Governments can continue to work with the private sector, to include information and communication technology providers, to help mitigate vulnerabilities. The private sector can provide insights on where the government support or intervention, such as through the development of best practices, the convening of industry and government partners, and the prohibition of untrusted equipment would be the most valuable. And lastly, government and industry partners can develop security capabilities that protect not only the 5G infrastructure, but also the applications and services that utilize it. The U.S. government can do this by incorporating a prevention-focused approach that focuses on visibility and security across the mobile network. Secure 5G applications and services will likely mitigate the risk of malware being transported across protected devices and defend against unauthorized command and control from exploited connected devices. Another topic I wanted to speak about today is open radio access networks. We developed a product with the National Security Agency through the Enduring Security Framework's public-private partnership. It is a focused review of current designs and specifications for Open RAN architectures. This product investigated how Open RAN security compared to traditional mobile network security and identified concerns related to the configuration of interoperable, multi-vendor radio access networks powered by cloud services and software. For those that may not know, Open Radio Access Networks is a concept where cellular networks consist of hardware and software components from multiple vendors. Essentially, an Open RAN is not a technology. It's more of an industry-wide interface standard that allows RAN equipment and software from different vendors to communicate. The goal of Open RAN is to lower barriers to entry and therefore promote increased competition, vendor diversity, and innovation. One of the key goals driving the deployment of Open RAN is the creation of a robust multi-vendor ecosystem that drives competition and innovation. The establishment of a multi-vendor Open RAN ecosystem not only creates opportunities for new businesses, both small and large, to enter the previously closed markets, but it also limits vendor lock-ins that can occur under the traditional RAN environment, in which the proprietary hardware and software are provided by only a single vendor. Open RAN has the potential to offer increased agility, resiliency, and flexibility in telecommunication networks by allowing service providers to select the best possible solutions from multiple vendors. Open RAN also builds on the security enhancements of 5G, extending the security benefits offered by virtualization from the core to the edge of the network. Open RAN also provides increased transparency into the RAN, allowing operators to see all aspects of the network and diagnose, remedy, and prevent problems in real time. There are, however, deployment challenges that may impede open radio access adoption. These include concerns about the maturity of Open RAN and its standards, the heterogeneous nature of the networks, and the difficulties that come along with ensuring that all those different components will be interoperable. Large traditional RAN vendors may introduce multiple components into an open network, undercutting smaller vendors and pushing them out of the market. Standards have the capability of being too cumbersome for some companies, and that may stifle innovation. In order to address these potential challenges, we identified 4 primary security considerations intended to support organizations as they build towards open RAN environments. The deployment of Open RAN introduces new security considerations for mobile network operators. By its nature, an open ecosystem that involves a disaggregated multi-vendor environment requires specific focus on changes to the threat surface area at the interfaces between the technologies integrated via the architecture. In addition to addressing security considerations related to integrating components from multiple vendors, service providers will continue to deal with other considerations related to the use of open source applications and new 5G network functions and interfaces whose standards are still under development. Additionally, mobile network operators will need to address security considerations related but not necessarily unique to Open RAN, such as cloud infrastructure, virtualization, containerization, and distributed denial of service attacks. Some of these security considerations include managing multiple vendors, which may increase the complexity of network administration, especially if trying to remediate a zero-day vulnerability across multiple platforms. Security for open fronthaul, which is critical for the confidentiality, integrity, and availability of radio access network data. Security of RWAPs and XApps, which automatically interface with the radio access network and perform automatic functions. And lastly, artificial intelligence and machine learning algorithms that manage network resources and support automatic anomaly detection and correction. And lastly, we have resources that are provided related to 5G and supply chain. You can find any of these products and services on the CISA website, which is www.cisa.gov. Both products I reviewed today, threats to 5G and Open RAN security considerations, will be made available to you after the presentation. That concludes my brief. Thank you very much, and I look forward to future collaboration.